So in week 5, we are going to talk about fractions. So an improper fraction is where the denominator is smaller than the numerator. So an example of that would be something like 4/3. So anytime your denominator, the bottom, is smaller than the numerator, the top. A mixed number is a whole number plus a fraction. So something like 2 1/3. That would be a mixed number. Now, I'm going to show you how to change back and forth between those two things. So 3 3/4 as an improper fraction. So I usually will write it less with that little slash on the 3/4. Usually mathematically, if you write it more of a distinct top and then your line and then the 4, it does tend to work a little better as far as looking at things in notation. So here, let's just multiply the denominator times the whole number. Now, the reason we do that is because if we want to break 3 whole pizzas into 4 pieces, we would get 12 pieces of pizza. So 4 times 3, denominator times whole number. And then all you're going to do is you're going to take that answer, 3 times 4 is 12, and you're going to add the extra 3 pieces that you have on. So 12/4 plus 3/4 is a total of 15/4. So let me talk you through it one more time. 4 times 3 is 12. 12 plus 3 is the 15. And we started out with fourths, and you notice our denominator carried along. Now, going the opposite direction, again, I'm going to write it like this, okay? What you want to do is, you kind of want to old school divide. I'm going to show you how to do it on a calculator as well. So if you were doing it on a calculator, you're going to do 29 divided by 6. Now, some calculators have like an ABC button, and if you put in the 29/6 using that ABC button, and you hit equals just on like a TI 30X or something like that, it will give you the mixed number notation. But I want to show you how, if you have just a standard, a good old calculator, and you do 29 divided by 6, what comes out is this weird decimal, 4.8333. So we know that we have 4 whole things. So 6 must go into 29 4 times. 4 times 6 is 24. But let's see how many are left over. 29 minus 24 is 5. We have 5 remaining, so we should have 5 6. Now, how can you check that you're right? Well, if you take this, should be 5 divided by 6 is 0.8333, and it is. And that's a way to kind of check your work. That decimal should line up with your proper fraction, and that whole number in front would be your 4. And that's how many times 6 goes into 29, and then this is how many are left over. So that would be your remainder if you did the division. And you can check your work. 4 times 6 is 24, plus 5 is 29, just like we saw up above. Now it says we want to think about lowest terms. Lowest terms is when the numerator and denominator don't share any common factors. So if you take a look at 8 and 9, and again, I do like to write my fractions like that. 8 is only divisible by 2, 4, and 8. 9 is only divisible by 3 and 9. They don't have any common factors. That is a fraction in lowest terms. But if you take a look at this one, again, I'm going to write it a little differently. You can break it down. Both top and bottom have a greatest common factor of 12. So if you know that, one thing I've always said is, hey, if you're unsure about what's really hiding there, hey, are they both even? They are. Divide by 2. And we get 12 over 18. Hey, they're still even. Divide by 2. You get 6 over 9. Now, they're not even anymore, but both of those numbers are divisible by 3, so we can divide by 3. And we get 2/3. Now, that's good. You can do it like that. Just keep breaking down. Is there a prime number that we can divide into those and just keep breaking down? But if we know right off the bat that 24 and 36 have a least common, well, I'm sorry, the greatest common factor of 12, and you can just divide by 12, you jump right to 2/3. So or maybe you saw, oh, they divide by 6, but if you do not stop until you get to the point where, like this one, it is in lowest terms. It says here, to convert a fraction to a decimal, divide the numerator by the denominator. So it is always top divided by the bottom. If you did it on a calculator, or if you're doing it on paper, top is on the inside, bottom is on the outside. So this is technically, again, I like to write it like that. Sorry, if I could write the number 9. That is the same as 5 divided by 9. And, or if we're doing it here like this way, that's 5 on the inside, 9 on the outside. Now, if you put 5 divided by 9 into a calculator, you get 0.55 with the 5s repeating. And then you'd have to see, well, how did they want me to round it to the nearest tenth, hundredth, thousandth? Let's go over this division down here. So put a little dot. 5 does not go into 9, so put that front 0. As you're going through nursing math, that front 0 is very important. It tells us a lot of information. Hey, we're something less than 1, so it's helpful, okay? And then add a 0. Well, 9 goes into 50 5 times. 5 times 9 is 45 without going over. And you'll notice we'd put another 0. We'd do it again, and it would keep being, it would keep being that 45, and then a 5 remainder again and again and again, however many times we decide to do it. So we get the same result. And you can do it either way, it doesn't matter. Okay. Now let's talk about adding and subtracting fractions. To add or subtract fractions, I'm going to give you a little note here. You must have the same denominator, and they call that common denominators. Okay, they must have common denominators. So again, I like to write this as 9 over 16 plus 3 over 25. I like to actually write it without the little slash. It does tend to work just a little nicer. Okay, so I believe it was week 3, mod 3, you were talking about greatest common factors and least common multiples. We need the least common multiple of 16 and 25 will be our common denominator. So that's what we're looking for here when we say common denominator. That least common multiple is really important. Now 16 is 2 times 2 times 2 times 2. 25 is 5 times 5. They have no common factors. So all we got to do then is we multiply 25 over here on top and bottom and 16 over here on top and bottom. So we kind of just flip-flop. 25 times 9 is 225. And 25 times 16 is 400. 3 times 16 is 48. 25 times 16 is 400. You should get that common denominator. And then to add the fractions, you must have common denominators. You are going to keep the denominator because that's the size of your pieces. I've taken that pizza, I've cut it into 400 pieces. Very tiny slices, I don't know. So 225 plus 48. I have 273 out of 400. Now you want your answer to be in lowest terms. So 273 over 400, you're looking to see if that reduces. They have no common factors. You're done. Okay, let's do another one. Now this time it's subtraction, but it doesn't matter. We still have to have that least common denominator. So again, we still have that 16, 25, same numbers, just subtracting. So you would again multiply this by top and bottom by 25, this on top and bottom by 16. We've already done the work converting them. So that's 225 over 400 minus 48 over 400. This time we are subtracting the tops and you keep the bottom. So we already know that the bottom will be 400. The top is going to be 225 minus 48, or 177. 177 over 400 does not reduce down any. They have no common factors. If they did, you would want to reduce it down as much as possible. Now, to convert from a mixed number to an improper fraction by multiplying the whole part by the denominator and adding that to the numerator and placing it over the denominator. Well, we already did that, but I guess we'll do another one. I'm sorry. Okay. So what does it say to do? It says multiply the whole part with the denominator and adding that to the numerator. That's exactly what we did. 3 times 7 is 21. We're going to add those 4 on. We're going to keep that 7. So it's going to be 25 over 7. Now again, you should always check, is there something that can reduce? If this number here was reduced off the bat, then you shouldn't have to reduce it. It should be in lowest terms. It says to convert an improper fraction to a mixed number using long division, there's a whole part and a remainder part is placed over the common denominator. We had done one like this, but I'll show you the calculator trick as well. So this is 32 over 9. Let me rewrite it because I don't like the way that that looks. And 9 goes into 32 3 times. Without going over, 3 times 9 is 27. And we got to subtract off 27 from 32. We have 5 remaining. So, okay, remember, we have 3 wholes. Our denominator was 9. This is where our remainder goes. Okay, so this is your whole part. Your denominator came over. This is your remainder. Okay. Another thing you can do is what the trick that they say down at the bottom. If you do 32 divided by 9 on your calculator, you get 3.555555 repeated. The 3 is your whole part. And if you just subtract off the whole part, your calculator will now read 0.55555555. And so what you can do, a little trick, is now that answer just multiply by 9. It'll tell you how many 9s it is. It's going to be 5, and so that'd be 5 over 9. So a little trick there. Okay. Now, to multiply and divide fractions, you don't have to have common denominator, but I'll show you what you can do. Okay. So I am going to actually do both of our multiplications first. Okay, so we'll call this problem number 1 and problem number 3. So we're going to do the 1 and 3 first. So 2/3 times 9/16. That's really helpful to rewrite it like I've written it. Okay, now I'm going to show you 2 different ways. Okay. To multiply fractions, we just multiply the tops with the tops and the bottoms with the bottoms. So this is really going to be 2 times 9 over 3 times 16. But here's a little trick. When you do that, you might end up with something that is not fully reduced. So here's my suggestion, okay? If there is a factor on top that can reduce down with a factor on the bottom, you're allowed to do that before you do the multiplication. Now watch what I mean. This number and this number are both divisible by 3. So let's do that. Let's divide by 3. We turn that into a 1. We turn that into a 3. Okay. This number here and here are both divisible by 2. So you can divide by 2, you get 1 and 8. Okay, so what's left on top? Now we can still multiply. It's reduced as much as possible. We just have a 1 and a 3. On the bottom, we have a 1 and an 8. See how it ends up making the multiplication easier? 1 times 3 is 3. 1 times 8 is 8. Okay, so now that's one way to do it. Another way, I'm going to rewrite the problem. Multiply tops with tops, get 18. Multiply bottoms with bottoms, get 48. I would notice, oh, they're both divisible by 2. Sorry, my writing here. Divide them by 2. You get 9 over 24. Oh, they're all divisible by 3. Divide them by 3. And you get, for a final answer, 3 over 8. So you can multiply first and then reduce, or you can reduce first and then multiply. I think reducing first and then multiplying, what it does is it makes it just smaller numbers you're dealing with, but be careful, as you go. Okay, now let's take a look at number 3. And I'm going to put a little dot for multiplication. The problem with number 3 is, what's the top that we multiply? What's the bottom that we multiply? It's not the same as number 1. So we have to rewrite those as improper fractions first. So let's do the little trick. 2 times 3 is 6. 6 plus 1 is 7. So that's really 7 over 3. We're going to do the same thing here. 6 times 4 is 24. Plus 5 is 29. There's nothing on the top or bottom that has a common factor. We're just going to go ahead and multiply tops with tops and bottoms with bottoms. 7 times 29 is 203. 3 times 6 is 18. There is no factor in 18 that's also in 203, so it's done. Sometimes you don't like to see it as a improper fraction like that. So if you do our little division trick, let me kind of show you over here. Numerator goes inside your division box. Denominator goes on the outside. 18 goes into 20 ones. 18 goes into 23 ones with a 5 remainder. You stop right there and you get 11 wholes, 5 remaining, 18 denominator. Okay, so in some contexts, this is a fine way to leave your answer. In others, you might want to do that. Okay, let's take a look at number 4. Oh, sorry. Now, we've done the multiplication. You multiply tops with tops, bottoms with bottoms, reduce if you can. Okay, now division is different. So let's do now 2 and 4. So number 2, that is 3/5 divided by 9/7. Back when I was younger, middle school, a long time ago, I learned a little thing about fractions, just a little saying that might help you. It's keep, change, flip. Keep, change, flip. It's just a silly little thing, but it might help. Keep that the way it is. Change the symbol to a multiplication. Flip. Keep, change, flip. Keep, change, flip. Who knows if it helps? I remember it from a long time ago. So, okay, so now it becomes a multiplication problem. And we do it just like we did problem number 1, tops with tops, bottoms with bottoms. I do notice that these two numbers are both divisible by 3. We can only do that reduction if we have actually flipped it first. Anything on top that has a common factor with something in bottom, we can reduce. So that would be 1 and 3. And now we can multiply tops with tops and bottoms with bottoms. So 1 times 7 is 7. 5 times 3 is 15. That can't reduce. Now you could have just done 21 over 45. They're both divisible by 3. It reduces down to 7 over 15. It's fine to do it like that. You decide, okay? Okay. Now, the problem with 4 is a similar problem we had with number 3. If we see 2 1/3 divided by 4 5/6, that's not good, because it has to be that numerator and denominator an improper fraction so that we can keep change flip. Okay, so first let's do a little conversion. Remember, we're going to multiply. 2 times 3 is 6, plus 1 is 7. That's going to be 7/3. 4 times 5 is 24, plus 5 is 29. Same numbers as before. But when you see that division symbol, you're going to keep the first number, change the symbol to multiplication, and flip over the last thing. Keep, change, flip. Keep, change the symbol, flip. This time, there is something that can reduce. 3 goes into the top number 6 and the bottom number 3, so you can make that 1 and 2. Just divide them both by that same common factor. Now we're going to multiply tops with tops, bottoms with bottoms. The remaining bottom. 7 times 2 is 14. 1 times 29 is 29. You notice we got a very distinctly different number by dividing them compared to multiplying them. And this time, that is a proper fraction. There's nothing that can divide into 14 that also divides into 29. It's in lowest terms. You're done. Okay, let's take a look at some kind of application problems. There are 36 patients on a floor. The nurse is responsible for a quarter of the patients. How many patients is the nurse caring for? So you can think of that as 36 is your whole number times 1/4. To multiply 36 by 1/4, you're going to put your 36 over 1. If you notice that 4 goes into 36, which it does, you can just divide, or we can multiply tops with tops, bottoms with bottoms. 36 times 1, 1 times 4, and then 36 is exactly divisible by 4 9 times, so that's 9 patients. It says the second nurse takes on 6 of the remaining patients. What fractions are they caring for together? Okay, so if you think about together, the first nurse it was taking care of 9 out of 36. The second nurse was taking care of 6 out of 36. That is 15 out of 36 patients. Now, you want to ask yourself, is 15 and 36 divisible by the same number? Can I put that in lowest terms? You can. These are both divisible by 3. If you divide the top by 3, you get 5. If you divide the bottom by 3, you get 12. And then just ask yourself, hey, did I do it again? So they are taking care of 5/12 of all of the patients. Let's look at this. It says, according to the Red Cross, 129 out of 300 people are blood type O positive. I happen to be O positive. Very interesting statistic there. In a group of 5,000 people, how many are blood type O positive? So here's a proportion. It's a very good thing to set up. So if you notice 129 out of 300, this is the O positive people. This is the total. Okay, so when you set up a proportion, you want to set up the other side the same way. I don't know how many O positive there would be out of a total of 5,000. So you see how the top is my O positive, the bottom is my total. It should be set up the same way I decide to set up the fraction on the left side. To solve a proportion, you always multiply the two numbers that are across from each other. The number you don't use, you are going to end up dividing, but I'll show you why. Okay, so you're going to do 129 times 5,000 equals X times 300. So back in the day, your teachers might have mentioned something about cross multiplication. It only is used in a proportion. That's it. So we can cross multiply. But what's happening to that 300? We're going to have to divide it off to figure out what x is, because the opposite of multiplication is division. So 129 times 5,000, let's get that number so we can write that down. That's 645,000 equals 300x. And see, look what happens. We divide by 300. And if we divide by 300, we get 2,150 people out of the group of 5,000 would have O positive blood. So that's a little bit about fractions. I hope that helps you understand that. Come and see me at the office hours if you have any more questions. Thanks so much.